Thank you, Anil. So, is there any particular doubt which you want to discuss before proceeding towards our sample questions? If not, so it's fine. We can go with our daily questions. Okay, then let's start. So, yeah, good evening, all. My name is Hitura Singh Rao. I am working as a Prime Minister Research Fellow in Department of Earthquake Engineering, IIT Roorkee. I am currently acting as an additional teaching assistant for this particular finite element course, which is NOC 24C85, finite element method and computational structural dynamics, which is currently being tutored by Professor Manish Rikhande, who is professor in Department of Earthquake Engineering, IIT Roorkee. The objectives of this 2 hour session, so those who are coming for the first time, so I want to guide that this particular 2 hour sessions is meant to interact with our learners, and accordingly we will also discuss some important concepts which is required to solve the assignment problems of your NPTEL course. Along with that, we'll be solving some of the sample questions which will be helpful in solving your assignment questions, and that will also be helpful in clearing your doubts related to the assignment questions. And if you have any other query which is related to the code, you are feel free to discuss that, and accordingly we can help you to as much extent as per our expertise. uh, One more thing, like those who are joining for the first time, so we will also circulate the videos. We are also posting these particular videos to the our YouTube channel. The link of that YouTube channel is being shared by the NPTEL team to you, and you can use those particular links and go and watch that particular videos. And so if not so let's start our first question. So today we'll be solving this questions on the same topic which we have deal with them in our last week. So we'll be solving the some of the questions related to the concepts of the two-dimensional and the three-dimensional finite element. So we are having question number one, which has been shown to you on the screen. So for the element shown in the figure below, you need to identify the quadratic shape function and to an n of Lagrangian and the serendipity family. Use the node numbering as given. Nodes in the middle of at age are its midpoint, and accordingly we need to evaluate the following. First, we need to evaluate the Lagrangian family shape function, and 2, which is evaluated at p. Lagrangian family shape function in it evaluated at p. Serendipity family shape function and 2 evaluated at p. Serendipity family shape function and it which is evaluated. So you can read this particular question, try for some time, and then after some time we are going to discuss this. So last week also we have calculated the interpolation function, and now we are going to solve the interpolation function using different thing, which is the Lagrangian family and the serendipity family shape function. So there are different methods. At 2 points you need to evaluate it using the Lagrangian family, and at the another point you need to calculate using the serendipity family shape function. Okay, so let's look to the solution of this particular part. So first we are going to calculate the shape function which can be evaluated using the Lagrangian interpolation function. So if you see what is the difference between the Lagrangian and the serendipity interpolation function. So in the Lagrangian interpolation we basically try to calculate the shape function using the intermediate nodal values also, which is available in a particular element. But in the serendipity interpolation function, shape function, what we try to do, we basically we don't take the polynomial terms which are corresponding to the intermediate nodes, and hence accordingly we don't take that nodes also into consideration. So these are the first thing. Let's see first figure which is having in front of us. So the coordinate of this function is p comma 1, then fifth coordinate is minus 1 comma 1, and you need to find the shape function value. Shape function value at coordinate 0 comma 0. So if you see, so the Lagrangian interpolation function is at any particular point is given by LIT of x multiplied with Lagrangian interpolation function at y. Right? This will be constructed. So if you see here, Lagrangian interpolation function x is given as the product of j is equals to 1, j not equal to 1 to p plus 1 divided by x minus xj xi minus x, and your Lagrangian interpolation polynomial y is given as product of p plus 1 j equals to 1 j not equal to x. Y minus yj and yi minus yj. So these are your Lagrangian interpolation functions given to you. Accordingly you can evaluate what is your shape function. So If you see in this particular figure, let me make it open frame. You are having, you can obtain the function values at this particular edges. Let me know what is the function value. So the function edges, the values can be obtained as y minus 1 is equals to 0, y is equals to 0, y plus 1 is equals to 0. Then here it is x minus 1 is equals to 0, x minus 2 is equals to 0. Accordingly, one more edge will be there. Which is given by x plus 1 is equals to 0. Therefore, the shape function can be obtained as so first we need to evaluate for the n2, right? So for n2, we need to calculate what is LIPX, right? So you need to take the equations of those edges into account, which is not coinciding with that particular thing. So here you are having the value, so let's say n2, so you need to consider this particular edge and this edge, and for the x you need to consider this particular edge and this particular edge. So x minus x with so LIPX will be x minus 0, right, into x minus 1, so which is x plus 1. So I am considering the x coordinates of this particular two edges, this node and this node. need to evaluate for the n2. What is the coordinate of n2? So here it is so the coordinate of second is how much? It's x is 3 comma 0 is 3 comma minus 1, right? So x minus x0. So for the n2 coordinate, so we need to consider the 0 x. So accordingly LITX we need to evaluate, so xi minus xj. So the coordinate which we need to consider for the sorry guys, just a call is taking tablet. Yeah, now it's fine. So for this particular second node you want to evaluate, so if you see the Lagrangian interpolation function, which is directly we can calculate what is the shape function available with you. So for the n2x, the shape function which is there with you, so it is the product of LITX and LITY. So you can evaluate what is LITX and LITY. So final n2x which we are having with us is minus y plus 1, y minus 1, x plus 1 and x minus 1. If you take the product of this is 8, then accordingly for n at x you can calculate it is x minus 1, x minus 3, right? Or n at y, so basically x minus 1 and then you are having x minus 1 and x minus 1, yeah, y plus 1 and then y you are having. So accordingly it's 16. So if you can calculate n2 and what is our point of interest is 0, 0, so you can see it's minus 1 minus 1 1 minus 1 by 8, so it's minus 1 by 8 minus 0.125. n2 is 0, 0, right? the answer which I'm having not correct at 0. Yeah, there is an issue with the answer. So it's a minus 1 by 8, and minus 1 by 8 is 0.125, and then you are having the n8. So if you put n8 as 0, so that will turn out to be 0, because once you put y input. So these are the values of the interpolation function at point P, if you are calculating it using the Lagrangian family. So that was about the Lagrangian family. Now you can try, so this is your first and second part. Now you can try with the third and the fourth part. So what is the serendipity family shape functions you can evaluate with the algebra. So how you can use the serendipity family shape function to calculate the interpolation function value at the node P. If you guys have any doubt, you can ask in the comments. So let's look for the serendipity function also. For this particular figure, yeah, for serendipity family shape function, this is the particular figure which we will take into account, because here we are avoiding the intermediate node. So accordingly, the higher polynomial terms which are corresponding to that intermediate node is also getting reduced. Hence, the figure which has been given to you is like this. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7. So these are the particular nodes availability. So let's mark this. This is x equals to 0. This is y equals to 0. Given to you. The equation of this line is x minus 4 is equals to 0. This is y minus 2 is equals to 0. So the point of interest is 0, 0. So p is equals to 1, 0.5. So this is the point of interest where we need to calculate the interpolation function value. So your LIP of x. So like you need to evaluate the NP at node value NP. So for this particular node, you are going to evaluate the interpolation function value at n7 and at n6. So first let's see what is the n6. So it will be like you'll be having LIP, so LIC PX L6 PY. So L6 PX will be, so you need to take this X values. So you will be having, so for L6 you will take this particular value, so that is X, and then you will be having the X minus Xi minus Xi. So you are having only one, so yeah. Then you are having L6. So for L6 py, you will take y minus 2, then y, then you are having xi minus xj. So what is your xi? So the function is given by, yeah. So it is given by xi minus xj. So for your L6, your xi minus xj. So this is this particular value. So it's 2 minus 0. Two minus 0. Yeah, sorry. So this is the thing. So xi minus xj in this particular case, since you are evaluating at 6, so it's basically 4 minus 0, then yi minus yj will be your 2 minus 0. What is y? 2 minus 0, sorry, 1 minus 0, and mm, so you are calculating this. So first you will take this minus this, so it's 1 minus 0, and then you will calculate 1 minus 2. So it's x into y minus 2 into y, and that will be minus 4. So your n6 interpolation function value is this. Now similarly, n7 will calculate like this. So for n7, your x is this, and then you are having x minus 4, your xi minus xj. So your xi, x coordinate of this part is 2. So 2 minus xj, how much is this? 2 minus 0, and then you are having 2 minus 4. Accordingly for the L6 py, L7 py, so you will be having only one function available with you, so that is y. x7 minus xj will be 2 minus 0. So the final answer which is here that is x minus 4 into y 2 minus 2 minus 4 minus 4 into 2 minus 8. Yeah. So that will be your n6 and n7. And once you are having n6 and n7 for the serendipity family function, your final shape function is usually given by yeah. So the n6 and n7 which you have evaluated are um, so n6 and n7 which you have evaluated are minus xy by minus 2 whole divided by 4. Then n7 is given by minus xy x minus 4 whole divided by 8. So accordingly your n2 will be given by your n cap x at that particular node minus half of n6 minus half of n7. Right? So n cap x at that particular node, if you see, is given by, so it has been added 2, so it's x minus 1. What is I cap j cap? So it's 2 minus 0 2 minus 0 and 4 minus 0. So it's basically xy by 8 minus plus xy what is n6? So n6 is xy y minus 2 and this is your 8 plus xy x minus 4 8 to the 16. So this is the final function value, and accordingly you can evaluate what is n2 1 comma 0.5. So this is n x comma y, and the final answer which I am having it is minus 0.125, and that is how you need to do. Sorry, that got erased in between. And let's see how we are solving for the n7. Let me draw the figure again. So for the n7 figure, this is your node 1, this is 2, 3, 4, and 4, this is 5, 6, 7, 8. So once you have this, this is your x equals to 0, this is your y is equals to 0. Here the function value of y is which we are having with you is x minus 4 is equals to 0, and here the function of y is y minus 2 is equals to 0. So now we need to evaluate the interpolation. Function value at p. What is p? Here is 1 comma 0.5, right? So your so this is basically given by what is your n approximate function available at xy minus your n5 approximate function x comma y. First you need to evaluate what is n5 x comma y within the Lagrange interpolation. So that is given by which is y into y minus 2, then you have xi minus xj, so this is 4, so put this 2 minus 0, this is 4 minus 2, and for the x it is given by sorry, this is different. So here it's y comma 0, here it's x comma 0. uh, my class is going on. So that is basically, here it is x comma 0 and here it is y comma 0. So your n5 will be x minus 4, and here it is xi minus xa. So what is your xi? Xi is your 2, so 2 minus 0, 2 minus 4. Accordingly, for the y, you are having y minus 2, and it is basically 0 minus 2. So the final answer which will be x minus 4, y minus 2, 2 minus 2, and minus 2. X minus 4, y minus 2, and it's basically 8, right? Similarly, for n6xy, you can evaluate like this. For okay, so you are calculating at 8, right? So this is the particular node. So you need to take it into account the n3x comma y as well as your n4x comma y. Sorry. So n3x comma y will change in size. So n3x comma y, you can calculate like this. So you are having x minus 4 minus 4, then here it is y, right? And so y is 2 minus 8, right? And once you have this, then you need to show the final answer and mention values x minus 4, x minus 4, y, that is minus 8. Similarly, your to solve it for n4 x comma y. So that is basically your x minus 4 and your y minus 2. So xi minus xj, so xi minus xj is minus 4, and then you are having yi minus yj. So y is 0 minus 2. So again the function value which is there with you x minus 4, y minus 2, and minus 4 and minus 2. So that is your answer. Then you need to evaluate n. So the final n which will come to you is x minus 4, y minus 2 upon 4. So accordingly you can evaluate what is the n of 1 comma 0.5, and answer which is there with us 0.56. So it's simple. In the serendipity family function, first you need to calculate the interpolation function at for example, if you want to use the interpolation family serendipity family function so of node 8, so in that case you need to first evaluate what is the Lagrangian interpolation function at node 3, Lagrangian interpolation function at node 4, and accordingly you can determine what is the interpolation function value at shape function using shape function init. So that is how you are going to evaluate the interpolation function value at the point of our interest, which is the point P, using this particular shape function init x comma y. So the final answer is 0.562. So that was about the first question. Let's move to the next question. If you guys have any doubt in the first question, please point it out. It's better if we can interact, means so accordingly like you can correct me and we can move further. Yeah, if you don't have any doubt, then let's move to our second question. You can look towards this question. So this is a big question of finite element. Just understand this, what is happening here. I'll just to give you a philosophy what how we need to proceed. The calculations are very large, so I won't solve the whole part. I'll just show you the final matrices which is available with me, and in between if you have any doubt we can point it out. हेलो, आप कहाँ पे खड़े हो भैया? हाँ, तो सिक्योरिटी को दे सकते हो क्या? ठीक है, तो सिक्योरिटी को दे देना, ऋतुराज के नाम से ना, दे दूँगा। हाँ, बात करा दीजिए। हाँ, मैं यहाँ पे विज्ञान भवन में रहता हूँ, C102 में। तो हेलो,
हाँ सर, मैं यहाँ पे विज्ञान भवन में रहता हूँ, रूम नंबर C102 में। तो ये पार्सल मैं अभी आ ही रहा हूँ 1 घंटे में, एक्चुअली मीटिंग है मेरा, तो आप इनको हैंड ओवर कर दीजिए, मतलब आप ले लीजिए, मैं आपसे ले लूँगा। मैं अभी 8:15 बजे तक आऊँगा। हाँ हाँ मैं हाँ, नहीं नहीं, बस अभी आ ही रहा हूँ मैं 1 घंटे में, बस आपको ले लूँगा। ओके ओके ओके, ऋतुराज ऋतुराज। ओके ओके।
This is a case of plane strain. So this is a case of plane strain. So definitely the main stress tensor which will be available with you will be sigma x, sigma y, sigma z, and then you will be having the sigma xx, let me write sigma y, sigma zx, and then we'll be having sigma xy. Because you are strained in the particular direction of the z, and as well as the, sorry, this is plane stress. So this is the case of plane stress element. So in that particular case you will be having only three elements definitely. So that will be case of sigma xy, yes. So your sigma is absorbed as well as your sigma xz as well as your sigma zx will be 0. So accordingly we can formulate our matrices. So the figure which has been given to you is like this. So this is a plane stress figure. The displacement vectors is 8, 7, 5, 6. So this is particular node 4, this is node 3, this is node 2, this is node 1. So 2, 1, that is 4, 3, right? So each node is subjected to sigma xx, sigma yy, and then one will be your shear node, right? So once you are having this, we can do the all calculations. So your final stiffness matrix which is available with you is given by k of t double integral -1 to 1 dt eb dy dx, right? So you need to, so this is your B matrix which can be obtained from your differential operator with the displacement uh, vector, and D is your matrix corresponding to your contributive model. So if you see this, how to get the, so your strain tensor is usually given by product of B with the stress with your displacement vector. How to get the B? So your B is given by for the case of the plane stress element is del by del x 0 del by del y 0 del by del y, then this is your del by del x. So it is given by ni 0 and j 0 and k and this is 0 and l 0. So this is your 0 and n 0 and j 0 and k 0 and l. So accordingly you need to calculate. So this is your matrix of the order 3 by 2 and this is of the order of how much 2 by 8, right? So your final matrix which will be available with you of P. So first we need to evaluate the shape functions and their derivative. So for this particular figure the shape function available with you are so now we are expert in solving the shape functions. So for n1 x comma y for this particular node n1, right? This is the node which I am talking about. This is your node. The coordinate is minus 1 comma minus 1, right? And the coordinate of this node is 1 comma 1. n1 is minus 1 comma minus 1 and n3 is 1 comma 1. So your n1 node n1 x comma y. So your shape function for first node will be x minus 1 as well as your y minus 2 and xi minus x2. So this is given by 1 minus minus 1 1 minus minus 1. So the x minus 1 y minus 1 and this is your 2 into 2. So x minus 1 y minus 1 and this is your 4. So this is your first. Then similarly you can calculate all the shape functions. So n2 x comma y is x plus 1 y minus 1 minus 2. Your n3 x comma y is given by x plus 1 y plus 1 by 2. Your n4 x comma y is given by x minus 1 y plus 1 minus 4. So accordingly you can derive the derivative which will be used in the calculation of your D matrix. So derivative is given by dn1 by dx which is y minus 1 by 4 dn1 by dy which is x minus 1 by 4 dn2 by dx which is given by minus y minus 1 by 4 dn2 by dy which is given by minus x plus 1 by 4, your dn3 by dx is y plus 1 by 4, your dn3 by dy is x plus 1 by 4, then your dn4 by dn4 by dx is minus 1 plus 1 by 4, then your dn4 by dy is given by minus x minus 1 by 4. So these are the derivatives. So once you have these derivatives, this will, so this B matrix, once you will multiply this, you will get a matrix of 3 by 8 order, and in this particular matrix we will be having some terms of the shape function and some terms corresponding to the derivative of the shape function. So that's why this shape functions as well as their derivatives with respect to x as well as with respect to y need to be evaluated, and once you can get this, you can calculate what is your B matrix. So the B matrix which is available with me in front of you is y minus 1 by 4, 0 minus y minus 1 by 4, 0 y plus 1 by 4, 0 minus y plus 1 by 4, 0, 0, x minus 1 by 4, y minus 1 by 4, x minus 1 by 4, 0 minus x plus 1 by 4, minus x plus 1 by 4, minus y plus 1 by 4, 0 x plus 1 by 4, x plus 1 by 4, y plus 1 by 4, 0 minus x minus 1 by 4, minus x minus 1 by 4, minus y plus 1 by 4. So this is the B matrix available with you, and accordingly, so this is the matrix which is known as strain displacement matrix. Once you have this, you can use the constitutive matrix. For plane stress problem, which is given by so once you have this B matrix, then accordingly you can evaluate your stiffness matrix, which is given by k of t integral plus 1 to minus 1 dt d b dy t. Thickness of the element is given to you, so you can use that. So once you have this k matrix, So you can evaluate this integral. So accordingly, once you have this matrix, you can calculate the B matrix at different Gauss points. So there are four Gauss. So for this double integral, you are having the four sampling points available with you. So, so for yes. So this is the stiffness matrix available with you, that is -1 to +1 bt EB dy dx. So you need to evaluate this using the 2 by 2 Gauss quadrature rule. So the sampling points available with you, if you check in that, is -1 by root 3 to -1 by root 3. bg2 is your 1 by root 3 comma -1 by root 3. Your bg3 is given by 1 by root 3 comma 1 by root 3. Your bg4 is given by -1 by root 3 comma 1 by root 3. So these are your four sampling points. Accordingly, you need to use the Gauss quadrature rule to evaluate your strain displacement tensor, your strain displacement matrices. So whatever you have written there, accordingly you have to calculate. So this is your 3 by 8 matrices. This is also your 3 by 8 matrix. This is your 3 by 8 matrix, and this is your 3 by 8 matrix. Once you have this, you can calculate for all the four cost points. So kg1, then we are having kg2, then we are having kg3, then we are having kg4. For kg1, you will be having first the gauss quadrature rule, which I applied using the first sampling point. So bg1 c t1 b bg1. Then accordingly you can evaluate bg2 t b bg2 bg3 transpose t bg3 d bg3. Okay, so you can evaluate this, and definitely your final k matrix which you are going to interpret is 1 into kg1 plus 1 into kg2 plus 1 into kg3 plus 1 into kg4. So these are the final stiffness matrix you will get. Once you will have this, you can evaluate what is your strain point, stress strain tensor at first gauge point. So that will be your strain displacement first some displacement at multiplied with your displacement vector. Displacement vector you can get it from here, which is u, and then whatever strain displacement matrices which you are having, which is 3 by 8, multiply with your displacement vector, which is the 8 by 1, uh, that will give you your strain displacement. So that is 3 by 1. Once you will get this, accordingly you can calculate what is your stress tensor at first gauge point. So that you can calculate using d epsilon g1. Your d matrix is 3 by 3, right? Your epsilon g1 matrix is your 3 by 1. Accordingly your stress tensor vector which you will get is 3 by 1. Accordingly you can calculate what is your sigma g2, sigma g3 and sigma g4. Once you have all this stress tensor available at all the four gauge points, so what has been asked in the question, so element d34 at gauge point near node 1. So first is this node 1, so this you can calculate using this bg1, and what is that, d34 of strain displacement matrix. So third term b34, so third row or fourth term you need to evaluate in this. Then what has been asked in the next question, k45 of the element stiffness matrix. So once your stiffness matrix is formed after summing up all these four stiffness matrix corresponding to four gauge points, you can sum up that, and then you need to show the k45 element. And then what has been asked, next epsilon x, epsilon y and gamma xy. So once you can get this, you need to evaluate epsilon x, epsilon y and gamma xy at cross point near node 1. So for node 1, you can calculate this strength tensor matrix, which is epsilon xx, epsilon yy, epsilon xy, right? And what has been asked next in the question? Sigma xx, sigma yy. So once you'll get this by multiplying with the constitutive model matrix with the strength tensor matrix, you will get it what is your stress tensor. So once you are having a stress tensor where you are multiplying your constitutive model matrix with the strength tensor, you can get what is sigma g. So that is a part of the four parts. Then you need to extrapolate values of sigma xx, sigma yy, and sigma xy at node 1. So yeah, you need to then form the interpolation function for the whole element. So how you are going to do that? So once you get that sigma g1, sigma g2, sigma g3, sigma g4, once you will get the stress tensor for all the four Gauss points, then you will utilize the shape function, and so which is given by command. So once you are having your stress tensor vector available with you, so that will be, you can utilize the shape function. So the shape functions, we are assuming that the shape function interpolates the stress field, and that's why your final stress field can be written as n1 sigma 1 sigma bar 1 plus n2 sigma bar 2 plus n3 sigma bar 3 plus n4 sigma bar 2, right? So how we are going to do that? So this is your corresponding to node 1, node 2, node 3, node 4. So if you will calculate the, expression component wise. The answer you will get it as sigma xx x comma y, which is given by n1 sigma xx 1 plus n2 sigma xx 2 plus n3 sigma xx 3 plus n4 sigma xx 4. Similarly for sigma x sigma yy x comma y, you will get it as n1 sigma yy for node 1 and 2 sigma yy for shape function 2 in 3 sigma yy for your node 3 and 4 for sigma yy for your node 4. Similarly sigma xy is given as x comma y and 1 sigma x comma y for first plus n2 sigma xy for 2 plus n3 sigma xy for 3 plus n4 sigma xy for 4. So you can use these four shape functions for four particular nodes, and that's how you can extrapolate. Now only thing is how you will get the sigma xx, sigma xx1, sigma xx2, sigma xx3, sigma xx4. So for each gauge point you need to evaluate. So once you'll get this, so since you can calculate the stress tensor, once you get the stiffness matrix, the stiffness matrix can be utilized to evaluate the strain tensor at all particular nodes. And once you have the strain tensor at all particular nodes, you know what are the sigma xx, sigma yy, sigma xy values available with you. You can combine them using the shape functions available with you, and finally you can extrapolate what is the sigma xx value in that particular field, sigma yy value in that particular field, and sigma xy value in that particular field. Yeah, so sigma xx, sigma yy, sigma xy. Yeah, so that was the part for, that is the solution for your fifth part. I know these things are means it's difficult to follow, totally understandable, but please watch the video once. I guess Mani sir has also explained the similar type of problem in one of his lecture. You can follow them, and the calculations are a bit hard, so doing it manually is difficult. So you can try either the MATLAB and the Octave to solve such type of questions. Once you have your own code ready, I don't think that will be problem further, and you can utilize to calculate your finite element part. So what is the time? It's 7:50. Yeah, so still we have some time left. If you guys have any doubt, we can discuss this. If not so, we can close our session for today. Okay guys, if there is no any doubt, let's close the session for today. If you have any particular query, we'll discuss it in next class. If not so, let's meet on next Tuesday at same time at 6 p.m. You can post your query in the chat box if is there any. Otherwise, we can close the session here. Okay, guys. Thank you so much. Thank you, Vanira.